Anand Varma took to keeping bees himself for his National Geographic assignment. With his incredible shots of bees from birth, Anand Varma has undoubtedly taken photography of the insects to the next level. 6 months in the making, the painstaking project came out of an assignment given to Varma in 2014 by National Geographic magazine, when the former biologist was tasked with snapping honeybees for a feature. This, on the surface, offered little opportunity for excitement or ingenuity. Apis mellifera is, after all, a well-documented subject of photographers. Nevertheless, Varma went above and beyond to find an entirely original angle on these fascinating insects. The result was a jaw-dropping time-lapse video that details the first 3 weeks of bees' lives up close. The bee's life cycle begins inside an egg. The incredible video lasts for just 68 seconds, including credits, and is made up of an amazing 2,500 individual images. It begins with a queen bee's egg hatching into a larva. In hatching, the soon-to-be bee takes larva form. Several larvae are then seen spinning around their comb cells, feasting on what Varma has termed the white goo emitted by nurse bees. This substance is more commonly known as royal jelly. Following this, the larvae begin to metamorphosize into pupae as legs and heads slowly emerge. The white goo in the larvae's cells is food discharged by nurse bees. The next step the video clearly shows is the process through which bees' tissues rearrange and their eyes develop. The bee's skin then contracts and darkens, and hair grows from their bodies. Then, with a few flaps of their new wings, the young insects are finally able to fly out of their cells. The larvae rotate in the goo, eating it all up. Varma decided that in order to capture something mesmerizing and unique about bees, the first step was to become a beekeeper himself. This way he would gain an inimitable understanding of the insects and be able to add something a little out of the ordinary to his assignment. The next stage of the bees' lives begins as the larvae change into pupae. As a result, Varma collaborated with beekeeper Alice Rosenthal, who, like the photographer, lived in Berkeley, California. Rosenthal had a beehive that looked unlikely to last through the winter, so Varma offered his backyard shed to accommodate it as a way of keeping the insects out of the cold. The head and the legs of the new bee start to take shape, and the shed would become a proving ground for Varma's eventfully masterful photographs. Helped by Rosenthal, he placed 2 comb frames into glass cases for observation. Next, he bored air holes into the shed to allow the bees freedom of movement. A different angle on the development from larvae to pupae. Now Varma had an arena in which to perfect his lighting setup, hoping as he was to work out how to capture attention-grabbing images of the bees. However, the bespoke studio still didn't allow Varma to see one key aspect of bees' lives, that is, their transformation from egg to adulthood. A varroa destructor mite can be seen in the top left of this image. Indeed, Varma could only witness the first 10 days of the 3-week process. This early stage involves the queen bee laying eggs within each cell of the comb. These eggs will be nourished and larvae will eventually emerge from them. Nurse bees then discharge food for the larvae and cover their cells within the comb. The varroa destructor mite is a major threat to pupae and will drain them of blood if given the chance. Fully grown honeybees then show their faces 11 days later. Varma, though, was already hooked and was determined to discover exactly what happened during that missing time period underneath the comb covering. The head of the bee now really takes shape as its tissues rearrange themselves. To capture this unique perspective, then, Varma moved out of his shed and into the lab. Specifically, he worked alongside beekeeper Billy Sink at the University of California, Davis Harry H. Laidlaw Jr. Honey Bee Research Facility. Gradually, its eyes acquire a pigment. The specialist lab's fridge-sized incubator is able to replicate conditions inside a larva's cell. This allowed Varma to place a small brood comb fragment inside the incubator. Hence, when each of the bees capped a cell, he could simply remove the cover without interrupting the development of the insects. Varma also set up a device allowing him to shoot cells for 7 days at a time. This cluster of bees are all going through the same process in the hive. Unfortunately for Varma and Sink, though, the process didn't go to plan the first few times around, and in the end it took half a year to get the amount of footage needed for Varma's final video. Now the bees are entering the final stages of their development. The finished video also shows the pupation process from above. Moreover, from this angle, it is possible to witness a parasitic mite crawling over the bee's brood cells. Known as varroa destructor, this creature is the biggest threat to developing honey bees. The skin of several of these bees is now visibly darker than before. The mite draws and eats blood from both the younger, developing bees and their adult counterparts. In this process, it will cause deterioration in the bees' ability to fight disease, which often results in them dying sooner. Indeed, a mite infestation in a beehive can destroy an entire colony. All that is left to do is to grow hair, which one bee has already managed. One of the more successful ways in which beekeepers have been able to defend their hives against mites was through the application of a particular poisonous neurotoxin formulated on the flowers of the chrysanthemum. With careful application of the chemical, it was then possible to eradicate the tiny mites without harming the larger bees. However, the mites have since become more resilient against this method, necessitating the use of a different pesticide. These 5 bees have grown their hair and are almost ready to leave their cells. However, in his TED 2015 talk, Varma highlighted another way in which scientists are attempting to combat the threat of the mites. Specifically, the photographer mentioned the trial breeding program being investigated at the USDA Honeybee Breeding, Genetics and Physiology Research Lab in Baton Rouge, Louisiana. Several of these bees' mouths have really taken shape. This program has successfully managed to produce a strain of bees that can fend off the varroa destructor. Unfortunately, these bees are unable to accumulate honey and also lack other natural behaviours. The long pointy tubes protruding from these 2 honeybees' mouths are called proboscis. Now, in an attempt to create a strong bee with all its natural traits intact, researchers are assimilating their bees with those of commercial beekeepers like Brett Addy, a man who, along with his brother, keeps more bees than anyone else on the planet. Many of the bees are now gone from their cells. In his TED 2015 talk, Varma also explained that his photographs underline the need to get to grips with bees' potential aggravators, as well as the insects' own biological makeup, in order to help them survive and thrive. In other words, he said, we have to understand bees up close. The skin of the central bee is starting to contract, ready for its hair. The best aspect of the project for Varna, however, was getting to know his bees, and while the photographer's schedule dictates that he won't be keeping any of the insects again anytime soon, his incredible documentation of his former hive means that he, and indeed all of us, can revisit the entrancing development of these bees again and again. Please do not forget to share this video with your friends below.